mathematics in our university. He has finished his PhD from Aligarh Muslim University in 2009. He received a prestigious postdoctoral fellowship in 2009 awarded by National Board of Higher Mathematics and Department of Atomic Energy, Government of India. Total impact factor of his research papers produced out of the PhD thesis is around 15 till date. He has qualified NAT JRF conducted by CSIR in 2003 and actively involved in teaching UG classes in Aligarh Muslim University earlier. He joined us in 2011. He has published 17 research papers in well-known and prestigious journals and referred conferences. So with all these written things, I want to add one more thing. He is our most popular faculty. We have 57 faculty members. So he is the most popular faculty. So we hope you will be enjoying the next 1 hour. One more thing I want to add. Initially we both tried to avoid each other. Ultimately we got coupled. And we made a group and we are riding together. Every time every moments of ours in this university are spent together. He is such a nice person. He will be enjoying next one. Thank you. But still, what's the
shades? देखिए अभी तो because I have to start my lecture, so I will say अंदाज़े बयां गर्ज बहुत शौक नहीं है, शायद कि उतर जाए तेरे दिल में मेरी बात. क्या? Which I start with. So the topic of my presentation is about intuitionistic fuzzy sets. So in this, I have just divided the content into 2 parts. In the first part, I do the comparison between fuzzy sets and the intuitionistic fuzzy sets. I briefly just define about the fuzzy sets and the representation of the fuzzy sets through alpha cut in the first decomposition theorem. Then, just to tell about the importance of the fuzzy sets, I just briefly discuss about the linguistic variable. To model linguistic variable, we need fuzzy numbers. Then, since fuzzy deals with the uncertainty, and in the intuitionistic fuzzy sets we have uncertainty together with hesitation, so we have to generalize the concept of this fuzzy sets, and to incorporate hesitancy in the uncertainty, we just say that it is more intuition based fuzzy sets. So the name is given by Atonosov intuitionistic fuzzy sets, so more intuition based fuzzy sets. And then there is an operation between intuitionistic fuzzy sets. You will just see that very basic mathematics is used for concluding the very good results. You will be just seeing that the very basic mathematics is used. The distance measure between intuitionistic fuzzy sets. We all know the metric. Actually, this is nothing but the simple distance function between the set. So in this, I will just show that whatever the distance functions are known today till now, all the distance functions fail to satisfy all the property of the distance function. So no distance function is available for the intuitionistic fuzzy sets. Still, we are just saying that in most of the paper, when I was just doing one dissertation on intuitionistic fuzzy set, I just find that I was unable to prove the things. So I was just trying to prove that it is a valid distance measure. So I just want to extend the normal Euclidean distance measure. So everybody was writing that it's a normal Euclidean distance measure, and so I thought that proof will be there. So in each and every paper, I find that the proof is trivial. The proof is trivial. The trivial thing is not written anywhere. Later on, we just find a counter example that it's not possible to satisfy the conditions. And rather the people have just written that the proof is trivial. If someone finds, you will just see the difficulty. If you could prove that thing, means it's the biggest result you could have, because that's why the similarity derived from these distance measure could not appropriately define that how much two sets are similar. So that's why the people are coming to the dissimilarity measure. They are just defining the dissimilarity measure. They are trying to do with different metrics, because they are not the true metric. So with different metric they are trying, but they are not finding the accurate result. But I will just be focusing that what we should do so that we can have a through this distance measure we always commit mistake, but we can minimize that. So it's actually minimizing our error. And then the application of those distance measure, and then the mathematician tried to just extend this distance measure, and they want to just give a different type of metric space. They just said that intuitionistic fuzzy metric space. But you will just see, I have not seen any of the paper practically it is being implemented anywhere. So I find that what's the reason that practical implementation of this intuitionistic fuzzy metric space is not possible. I will discuss that also. Why practical implementation is not. So here the thing is that the two problems you will just see which are very important is first to define a proper distance measure, and then how intuitionistic fuzzy metric space could be properly defined so that it could be used in some pattern problem or somewhere if we want to take some decisions how we should properly define this intuitionistic fuzzy metric. If we could do something in this intuitionistic fuzzy metric space, then it will certainly be a good thing which we will put in our research things. Okay, so I just start my discussion with one paper of Zadeh which was published in 2011 and a special issue of Applied Computational Mathematics. In the first issue of the volume 10, from page 4 to 9, he had written his autobiography, My Life and Work, a retrospective view, in which he mentioned about that very point which brought the concept of fuzzy sets in his mind. And that was the unsharpness of class boundaries. Since unsharpness of class boundaries was not considered in science engineering, so it drew mixed reaction. So what is that unsharpness of class boundaries? Whenever we think of a set in a classical sense, I am just drawing it. So if I just want to draw a circle, so what should be the function? The function should be, f should be a function from r to r2 such that f of theta is equal to a cos theta and b sin theta. So basically what I am just trying to say that I have just given a function from r to r2. Okay. Now from this function, what I have done, I have just, I have drawn a circle. Now this circle, the boundary of this circle has bifurcated. If I just take, this is the whole universal set. So this boundary has bifurcated the whole space into two parts. One, the points which are lying within the boundary, and other which are lying outside the boundary. Now the points which are lying within the boundary, they are different. The points which are lying outside the boundary, they are different, we are just considering. So, what we say that each element of the universal set is bivalent in nature. Either I can associate a value 0 or I can associate a value 1. Associating a value 1 means that I am just saying that it is a member of this set. And x is equal to 0 means it is not a member of this set A. Now this is what this decision we could take because of the sharpness of the boundary. Because of that, we could draw this. We could chalk out this. That's why we could take this type of decision. But once this boundary is missing, we could not draw the boundary. Then how to take the decision? Something, it is lying within this boundary. It is lying outside the boundary is missing. Then the concept of fuzzy set, the boundary is missing. Like if I just say that the class of old people, So this is context dependent term. Once a 10-year child, if you have a 10-year child and he is applying for the nursery admission, what a school will tell him? It will tell him he is old. He is not fit for that. Even the age of the child is just 10 years. So he is old for that. Similarly, for some job, if someone is applying and then the company has fixed that, okay, 25 years is the maximum age, and after that I am just treating the person to be old, not fit for this job, then certainly 25 years is old. So it's a context dependent term. So we have to just understand that old in which context? Old in which one is, like me, myself, if I ask that what you are going to say about me, whether you are going to put me in the class of old people or young people. So the difference of opinion will occur. Most of you will say that, oh, you are old, you are old.
More fittingly young. More fittingly young.
But someone like sir, I'm very happy because I consider myself also young. For this I say my looks are often deceptive. Don't go to looks. Okay. So the thing is that I may consider myself to be young. So the thing is that there is a difference of opinion. There is a difference of opinion about the age, that whether a person should be put in the class of old people or not. So seeing the features, one is deciding about that whether I should put him in the class of old people or not. So you, after seeing that they notice that okay, 50% or 40% features are matching with the class of old people. So you should be 40% a member of that set, and 60% features are not matching. So you are not the member of that set with 60% degree. So what one is trying to say, that an element simultaneously hold two characteristics. One, he is members, and simultaneously a person is not a member. So you are simultaneously, you are just saying that an element just has two types of characters simultaneously. One, he is a member, he is not a member. So once he is a member, so someone is saying that 0.4, now not a member, so we directly derive 1 minus 0.4. So how to just give this membership value? So we define a membership function. We define a membership function on the whole universe of discourse X, and this membership function, it should be defined in such a manner that the range should be between 0 to 1. But only the thing which we have to keep in mind, that our membership function should have a beauty that it should be defined over the entire domain, and its range should be between 0 to nothing else we need. Continuity, discontinuity, correct about everything. Only one thing you have to just remember, that your distance function, your membership function should have a beauty that it should be defined over the entire space, and it should be from 0 to, and the range should be 0 to 1. Here what is the non-membership value? Automatically someone is saying that 40% an element is a member of that set, then 60% is not the member of that set. It is automatically taken here in the fuzzy sets. Okay. If geometrically, if I want to see what is happening in this fuzzy sets, because geometrical intuition, you will find that it's basically, it will create a kind of picture in your mind, and then we just can understand that whether we can use this thing in our problem or not. So this geometry, I'm just trying. I just say that this mu ax, and what is this? Plus mu ax, mu x is equal to 1. Actually, this is the thing. Mu ax plus mu x is equal to 1. I just take mu ax is the membership value along x-axis, and the non-membership value along y-axis. So I just represent, for simplicity, I just represent this term. This is one variable. I just represent it by x, because we are very comfortable with x and y. Once we easily write in terms of, I represent it by y, and I ask what is this in 2 dimension. Everybody will say that it's a straight line. It's a straight line. A straight line making an intercept of 1 unit on x-axis and y-axis. So actually, whatever the value one want to define, it will always going to lie on this intercept. It is always going to lie on this intercept. Means whatever the value is there, and the expert is going to define, it is to be defined on this line. Okay? Then actually I have just talked that boundary is missing somehow in the fuzzy sets. Boundary is missing. So without boundary, if you want to do any mathematics, it is something very difficult. So we want to bring the concept of that boundary again artificially, if we could do. So there is a alpha that the people have defined for finding the concept of boundary. They have defined the concept of alpha cut. So alpha cut is actually, again in the fuzzy set, the concept of boundary is again brought back. How they have defined? They have just taken that I am taking the collection of all those elements from the universal set whose membership value is greater than or equal to alpha, where alpha is any number between 0 and 1. So once this thing is defined, so boundary is only defined when the set is crisp in nature. Boundary is only defined when the set is crisp in nature. So we have to check whether this set is crisp in nature or not. So whatever the value I am going to pick from the universal state, I have defined the membership value or membership function already. So it will give the membership value. It will give the membership value. Once we have a membership value, we can compare whether its value is greater than or equal to alpha or it is less than or equal to alpha. So once we have checked that okay, the element value is greater than or equal to alpha, so we will say that it is within A. If it is not, it is less than it is outside A. So again we have a concept of boundary, and in this way we have artificially brought back boundary here. So we have just formed the crisp set out of a fuzzy set. Now with this crisp set, again it has helped us in finding how to define fuzzy sets using crisp sets. And this is called the first decomposition theorem. Means defining fuzzy set with the help of crisp set. Because this is the thing which we want to, if we want to bring mathematics, good mathematics, we again have to come back to somehow crisp set. See, somehow if we are just trying to do, we will just be doing that. So first decomposition theorem. So first decomposition theorem, it's a very simple thing that this is a statement, but for this statement I just take an example to just explain, because proof I am not going to write. So I just take an example that you have a x1, x2, x3 and 5 element in the universe of discourse. And each element is somehow given a value. X1 is given 0.2, x2 is given 0.4, x3 is given 0.6 and x4 is given 0.8 and x5 is given 1. Now the alpha cut of 0.2, we just find the alpha cut of 0.2. So A.2, what is A.2? A.2, all those elements whose membership value is greater than or equal to 0.2. How many elements are there? Only one. So I just write x1 with 0 and x2 with 0, x and 0, x3 and 0, x4 and 0, x5. Similarly, 0.4, it is 1 with x1, it is greater than 0, and this is greater than or equal to. So it is greater than, it is 1. It is 1. Everywhere is 1. It's 1. Here it's 0. It's 1 and it's 1. It's 1. It's 1. So in this manner I just 1. So here it will be 0 x1 and here it will be 1 x5. So I take the union of this. Taking union means taking the now again what in here it is small a alpha. Small a alpha is the alpha times the crisp set. So again we just converted it into crisp set is converted into fuzzy sets. So it is 0.2, 0.2, 0.2 and 0.2 and 0.2 and again it's 0.4 alpha times. 0.2 times, 0.4 times, so it's 0.4, it's 0.4, it's 0.4. So just take the maximum of this. What is the maximum of this? 0.2. Union, maximum. So x1 is again with 0.2. Again, I will just see that here it will be 0, 0, 0, 0. Again, the maximum is 0.4. So again, we are getting back the same set. So we have represented the fuzzy sets with the help of alpha numbers. With the help of alpha numbers. So this is the decomposition theorem with crisp set and the relationship between fuzzy sets. After this, linguistic variable. A variable whose values are words rather than numbers. So, for example, performance. So the thing is that fuzzy sets is basically in 1973, when Zade has introduced this concept of linguistic variable in the same paper in 2011, what I have just read. If you go through that paper, you will just find that Zade has written how he had developed the fuzzy sets, and it is a very good paper. He had written about his life. So there he had just defined that in 1973, whatever the criticism he was just facing, it was removed because he could just convince that there is a linguistic variables, a variable whose values are words rather than numbers. And if the example is performance, performance is something which may be input may be performance is good, performance is bad, performance is worse, performance is excellent, something like that we just define. So actually mathematically a variable whose states are fuzzy numbers assigned to relevant linguistic terms. So performance is assigned a relevant linguistic term. Performance is high, performance is low, performance is very low, performance is excellent. So actually now these terms, relevant linguistic terms, should be defined in mathematical terms. What it is just saying, we would just try to define it in terms of mathematics. So it is just saying that defined in this term, like defining something in terms of numbers. Defining something in terms of numbers, so I can compute. So the things could be computed. Here it is fuzzy. So the thing is that you define in terms of fuzzy numbers, and fuzzy numbers should be properly defined. Should be properly defined so that these terms could be computed. Mathematically we can do some computation. So how these fuzzy numbers are just defined? Just see that the performance say the performance of the student. So the performance of the student, if we just say that it's below 40%, we say that it's worse. Here he is failed. And then we say that he is in the D grade, and we just grade him. And then if he scores from 40 to 60, we say that okay, it's satisfactory. It's satisfactory, okay. But we just say that its grade is C. And then we just find that okay, from 60 to 80, we just find that he is somehow good. He is good. And then above 80, I'm just trying to say that above 80, I'm just trying to say that he is excellent. These are the 4 grades I have just decided, that the student is excellent, student is good, student has satisfactory performance, student is but he is performing worst, he is not performing, he is performing very badly. So how to just give a kind of, so what is this? From 0 to 40 there is a range. What is there? 0 to 40 there is a range. Whatever the number here it will come, I will say that it is from, the student is from group D. The student is from group D. If whatever the number I find from here to here, 40 to 60, I will say the student is from group C. If I see that the number is from 60 to 80, I will say that the student is from group B. If it is from 80 to 100, the student is from group D. Now the thing is that the student may be very close to 0 and the student may be very close to 40. So these two scenarios are different actually. These two scenarios, someone has performed badly and badly in that also in the worst form. And someone is just, the student used to say, sir, I just failed by 1 number. Oh, then, so there is something like that. Okay, we should be sympathetic. If someone is telling that, sir, I got 2 marks, so Go, get lost. You deserve this. So the thing is that, so these two things are different in our mind. So these two things are different. So how we are going to say these two things are different? So what we are just trying to say that, okay, we just say first this group, this particular interval is selected for D. If we just say that, actually I am just saying if someone is getting exactly 40, then I am just trying to say that he is bad. And now before that he is very bad. Actually I am just saying that he is very bad. So actually what I am just saying that 40 is the membership. Exactly, if you are getting 40, then you are bad. So membership value, what I am trying to say, 40 to 40, I am just saying that, okay, you are bad in the sense which I am just trying to say. So from 0 to 40, 40 is the value where we have a membership value is 1. Means we are absolutely sure that this 40 is going to be in this interval. Means for D, we should select this interval. It is based on our confidence on some point. Some point should be there that to select that interval. Some point should be there where we are going to be absolutely sure. Absolutely sure. Otherwise, we cannot pick the interval. To pick the interval, some point, at least 1 point. So what we are trying to say, the fuzzy set should be normal. Fuzzy set should be normal. What is the fuzzy set? Fuzzy set is nothing different. It's a membership function. We are just attaching X with the membership value. X with the membership value. Now on R, it's, so what we have just said, that okay, this interval should be selected because I have 1 point of confidence. 1 point of confidence, if I just saying that okay, this is the point of confidence for T. So second thing, whose support is bounded. Whose support is bounded. The thing is that the function, whether I can choose this type of function or not, fx is equal to 1 upon root 2 pi sigma e to the power minus x minus mu, which is the normal density. This is the normal density. If I just, this is defined over what? This is, the domain is, in the fuzzy set, the domain is any set x. Here the domain is real numbers. So it's a function whose domain is real number. Okay, so I can just think of this. But in fuzzy scenario, don't try to write like this, because in that case this x is not a number. For number we can write like we have this type of whose domain is R from. So I have just written this. What we say about the support? What is the support? Support is the set of those points which are just supporting our whatever the definition we have just taken. This is the definition we have taken, that bad and numbers I have associated. So those elements which are supporting our definition. Actually, whatever the assumption we have taken, those elements which are supporting them, means supporting that whose membership value is greater than 0. Whose membership value is greater than 0. All those x in X such that the membership value is greater than 0 is the support of A. Means all those elements where the membership value is 0, what does it mean? It is outside this interval. Okay? 0. So those elements which are supporting our definition. So we just want that this support is bounded. So whether we can take this function or not, this is the question. Whether we should take this function for defining the fuzzy number or not. Here, is it the support is bounded or not? So my question is whether the support of this is bounded or not. Bounded means a set whose lower bound and upper bound exist. Lower bound and upper bound exist. So whether this has an upper bound or So where its value is 0, just we see where its value is 0, x tending to infinity, x tending to at infinite point its value is 0. And for all the other point, what is the value? It's non-zero. So the support is unbounded. So this type of function is not going to work for modeling the situations. Okay, fuzzy. This will not be a fuzzy number. This will not be a fuzzy number, because for fuzzy number the support should be bounded. That's why we use the trapezoidal. It is either trapezoidal or triangular or something like that. It's coming back. Okay. So the support is bounded, and whose alpha cuts are close interval for all alpha lying between this. A triangular fuzzy number and the trapezoidal fuzzy number, we just see that these are the two very important fuzzy numbers which we use for modeling the situation. This is something, triangular fuzzy number. Here what we are just trying on 0 to 40, what we are just trying to find that okay, 40 is our 100%, we gave the membership value 40 to 1, and then this value, this is 0 marks, we gave the membership value, we just try to join these 2 points A and B, find the equation of these lines, and then we just find that this is the thing which we are trying to model. We are trying to model by this type of thing. Here the only one point is there on which we have absolute confidence. If more than one points are there on the absolute continuity, say this is, there are number of points on which the absolute continuity. So it's better to model the situation with trapezoidal fuzzy number. And then, so the fuzzy sets, we have just defined that fuzzy sets is actually, in terms of information, Smith and Kaprasik had reproduced the definitions of grid set, fuzzy set, intuitionistic fuzzy set. Grid set, information is complete, elements fully belong or fully not belong to a grid set. Information is complete, but the elements can belong to a fuzzy set to some degree. Knowing the degree to which the element belong to fuzzy set, we immediately know the degree to which they do not belong to the fuzzy set. In intuitionistic fuzzy set, information is incomplete. Even here, whatever the information we used to give in the fuzzy sets, it's a subjective information. That's why the things are not crisp in nature. But in that, those information, we deduct those informations also. We are not giving the complete information. I am just taking an example. This is somehow I have just, I find this type of presentation when I was in IEEE first. So, one person has given this type of, this is in his slide. So I have just copied that. So what is there? I have just taken. I am just saying that it's a person who I have just selected from the matrimonial site. Okay, he has just given his biodata in some matrimonial site. Okay. Now what happened? Once the thing is there, if it is just proposed that whether a person is suitable for match or not. So what will be the answer? The answer will be like that. Okay, 70%. Okay, maybe someone is saying 30%. Okay, I will decide after looking other things. Okay, somehow I have given the distributed the biodata also. So nobody is going to say 100%. Okay, this is what the things I was just looking for. No. The thing is that they will say that okay, the thing is that we will look into other things also. I will take decision looking a lot of things. Okay, so even if all the information, the biodata is also given, then also one cannot, one doesn't take that okay 100% I am going to take a decision or not. So this is fuzzy. But if I just miss the biodata also, if I miss the biodata and the picture is there with three things, then what will be it? It will be a more confusing situation. And then the thing is asked that look, and then you have to decide what you are going to say about this. Then the thing is that whatever the 70% was there, it will be deducted. And the people will say that okay, this is 30%, now 30%. And the thing is now it is 15%, the non-membership, or 40%. And 30% and 40% is the hesitancy. Once you show the biodata, then I am going to decide about the things. So the thing is that even half of the information, So information was subjective, and even in that also some of information is still missing. So the concept of hesitancy is also appearing with uncertainty. So in intuitionistic fuzzy set, the concept of hesitancy appears with uncertainty, because what we have detected certain information. Okay, information is not complete. So intuitionistic fuzzy sets. So what to understand intuitionistic fuzzy sets? What we have to define? Only membership value is not a correct description, because what it will create? 1 minus this is the non-membership value. You do not want to say the non-member also. So this much non-membership value. You want to say 30% membership, 40% non-membership, but 30% hesitancy you want to keep that. Because once I look the biodata, I want to change, I want to modify the things. So you have to define the membership function also. Simultaneously you have to define non-membership function also to understand the fuzzy intuitionistic fuzzy set. That's why I said that it's intuition-based fuzzy set. It's an intuition-based fuzzy set. So again, what happens? It's the membership value plus non-membership value. Sum is always going to be between. The only condition required is the sum of membership and non-membership value should be between 0 and 1. Okay, so there is a new term which is appearing here. What is that? That is a hesitancy. So mu a of x plus nu a of x plus pi a of x is equal to 1. Now this is the thing. So if I just represent it by x plus y plus z, so how many dimensions are there? How many different? Three. So it's what? It's a plane. It's a plane which is passing through x-axis, y-axis and z-axis, making an intercept of 1 unit on x-axis, y-axis and z-axis. So the fuzzy set is the membership and non-membership value is on a line. In intuitionistic fuzzy sets, the membership, non-membership and the hesitancy is on the plane. These are the certain operations we all know in fuzzy sets. If A is contained in B, so you just see it's directly derived from there. It's very naturally developed out of a fuzzy set. Just say A contained in B in fuzzy terms. What is that? Mu of A of x is less than, we all know, mu B of x. So what is the, if I just multiply it by negative sign on both the sides, what it will be? Minus mu A of x is greater than or equal to minus mu B of x. If I add 1 both the sides, what is this? Inequality is not good. It's nu A of x is greater than or equal to nu B of x. This was automatically holding in the fuzzy sets. In the fuzzy sets, it was automatically holding. Here, we have to just say that this condition should hold. So we have specifically, we have to add one more condition about non-membership. This condition was automatically holding in fuzzy sets. But in intuitionistic fuzzy sets, we have to add one more condition about non-membership, that this should hold. This should hold. Similarly, we know that when A is equal to B, mu of x is non-membership value. This is minimum and this is maximum and all the things we are just distance measure between intuitionistic fuzzy sets. So now the important thing is that once the description is given in terms of fuzzy sets. Now the description is given in terms of fuzzy sets. Now you are just telling your opinion in terms of fuzzy sets or intuitionistic fuzzy sets. So how much opinions are, my opinion is differing with the opinion of someone else. We have to, how much similar those two opinions are. This is the most important thing after that. To find the similarity between the two opinions, how much similar two opinions are, how much dissimilar those opinions are. Actually, you just think that in mathematics, if we have to say that the 2 points are similar, what is in our mind? They are very close. They are very close. They are very close. So what is very close means the distance between the 2 points is very, very small. So we can just say that these 2 points are very close. Otherwise, the distance, if the distance is more, we say that these 2 points are far away or very different So here also, in terms of distances, we just compare the opinion. Whether the 2 opinions are same or different, we just take out the distance. If the distance is less, we say that the opinion is very close. If the distance is more, we just say that these 2 opinions differ very much. Okay. So you just see, this is the distance function. Usually, what are the? It's a function from, D is a function from intuitionistic fuzzy set X to intuitionistic fuzzy set X to 0, 1, and this DAB satisfies these 4 conditions that the distance is always going to be between 0 to 1. Actually, distance in ordinary sense, it can take any, it's a non-negative number. Here what we are just saying, that automatically, since we have just given in terms of opinion in terms of fuzzy set, then what we just want that the distance should be between, we just want to find the distance between them should be between 0 and 1, so that we can compare that this much distance 6. So distance between AB is equal to 0 if and only if A is equal to B. Distance between AB is equal to distance between BA. These 2 are taken directly from the distance measure, 2 and 3. The first is only that in the fuzzy, in usual distance metric, what happens? It's a function from X cross X to R, non-negative real number. Here, what is this? It's a function from X cross X to 0. We have to take the metric in such a manner, we have to define our metric in such a manner that its value should always come between 0 and 1. Now A contain B contain C means 3 A is contained in B, B is contained in C. So just A is contained in B, B is contained in C. So this is A, this is B, this is C. If you just take any point from here and I take its distance from here and its distance from B from this point somewhere from here and just distance between AB and this is distance between AC. I am just taking from the center, I am just taking distance between AB and distance between AC. What type of relation is existing? Distance of AC should be greater than distance of AB. Similarly, distance of AC should be greater than distance of BC. Whatever the distance I am just trying to say, BC. Okay, B to C. So the thing is that distance between AC should be greater than this containment is there. A is contained in B means what I am just trying to say, A contained B, mu A of X. Because from here it is not very visible, very clear, because this just if I write it mathematically, I am also more comfortable when I write the expressions. Without expression, I become expressionless. so I just want to write the thing. So mu A of X, A contain B contain C, mu of A of X. What does it mean? Mu D of X is contained in mu C of X. Mu A of X is less than or equal to mu B. Greater. Mu D of X is greater than or equal to mu C of X. Just take the difference. So if I take this difference and this difference is greater than this difference. Simultaneously, if I take this difference and this difference, so this difference is greater than this difference. So what I am just trying to say actually, what is the distance between in 3D? What is the distance between in 3D? Usual number. If X is equal to, don't take it mu. X is equal to X1, X2, X3. Y is equal to Y1, Y2 and Y3. What is the distance between these 2 points? X1 minus, I just say X1 minus Y1 square plus X2 minus Y2 square plus, this is a Euclidean distance. I am just taking for simplicity. So this is the thing, this is the distance between x and y. Only the thing is that here what is this? This is mu x, mu ax, mu bx, mu, and this mu x, mu b, and mu c. So if we have to just find the distance between fuzzy sets A and B, so what will be this mu ax, just see, minus this, here it is written Hamming distance, but in the next slide I have just written the so this is simply mu xi. I don't want to. So this is this. We are just writing like mu axi. Here one thing is there that this it should be 2n actually 1/2. It will not make the number between 0 to, and so it should be 1/2n. So the thing is that actually this is nothing but from A to B. You just see that once I have taken the difference mu b minus mu c, this difference and this difference. This difference is greater than this difference. This difference is greater than this. These two difference, and this difference is smaller than this one. So what is there? The third property is automatically satisfied in this case. We can just see. But actually, what is the thing? What is in fuzzy sets? I just first write the thing in fuzzy sets, and then I will explain this. So I think udhar is. So this is the counter example which I have just shown, that you take the distance between AB in this case. Although you just see A is contained in B, B is contained in C, but distance between AB by Euclidean distance measure and distance between AC, we are just finding distance between AB is greater than distance between AC. By that measure, when we try to find out the thing, we find that actually this is not a valid distance measure. But in fuzzy, this is mu A x contained in mu B x is always this is if I just in terms of mu this mu x, I have just told you this automatically satisfied. So what happens whenever we take the distances? So A contained B contained C implies that that is a valid distance measure. But in because of the hesitancy, you just finding that this is not happening here. So with the help of this distance measure, similarity is defined. Similarity is the negation of distance measure. One minus the negation of the distance measure. This theorem is being proved by Mitchell, and I have just seen in the paper of Mitchell, which I have given in the reference. So we can go through that. Now, with the help of this, what the people when tried to solve, actually the distance measure has no problem. When they tried to find that it's simply 3 points, 1 0 0 0 0 1 0 0 0 1. So they tried to find that actually the distance between AB and the distance between BC and distance between AC is same by Euclidean distance measure. Now you just read out this. This is the opinion of 3 experts about 3 different situations. That persons supporting, there is a 10% voting model. In that, to some expert, all the 10 persons have told that they are going to support him. And another expert and another person had gone there, and he asked that whom you are going to support. So they said that no, we are not going to support A, that person. We are not going to support. Exactly, they said no, we are not going to support him. Then the third expert came. So all of them told that okay, we don't want to tell anything to you. So they become hesitant. They are not telling they are not expressing their opinion. So this is 3 different things. So once you are just finding what is if I just find the distance between AB. So what is this? These 2 opinions are entirely different scenario. What it is still telling? It is telling that one is telling that they are going to support 100% A. Another is telling that they are not going to support 100% A. So the distance between AB should be greater than the distance between this AC. entirely different situations. Entirely different. Here, the thing is that in C persons are hesitate to support that particular man. They are just say that they are hesitant. So this is a something slightly lesser degree of displeasure. Okay. So these, when once we find that the distance measure is same, what does it we are saying? That they are actually equally distance measure. They are similar. All these situations we are saying that all these situations are similar. And driving some result out of that means somewhere there is a problem. Somewhere there is a problem. Because it is saying that all the situations are similar. So what is actually the thing that in the fuzzy sets I have just why I have drawn this line. So A contained, B contained C. This is the opinion of A on this line. A contained B means it is mu AX. A contained B means B's opinion will be A is contained means mu A of X is smaller than mu B of X. So A contained in B. A contained in B mu A of X. I just want to. It is mu B of X. So mu A of X is this, and mu B of X is here. So it should be here. Okay, it should be here. This is mu A of X, and this is mu B of X. And here there will be situation that A contained B contained C. So what is how much mistake we can commit? This situation, the distance between from here to some point and equidistant distance from here to here, some point may be same. It is same. But what we have put the condition, A is contained in B is contained in C. So we are not taking those points. So that's why in fuzzy sets, this distance measure is working. This distance measure is working. But in intuitionistic fuzzy sets, you are just seeing that it is on the plane. It is on the plane. So once I have expressed my opinion in terms of intuitionistic fuzzy sets, and what is this actually? X square plus y square plus z square is equal to, this is the distance meter. I am just writing mu A by X, y square plus z square is equal to some constant number A square. What is this? This is you have just intersected the sphere with a plane. So what will be actually the intersection? Intersection of a sphere and a plane is actually a circle. It is actually a circle. So what you are trying to say actually, look, this is the point, this is the thing which I have expressed, and then you are just whatever the points on this circle, equidistant circle, you are by this distance measure, it will just say all these points are same. All these points are same. So this is a big mistake. And here, what is this? 1, 0, 0 and 0, 1, 0, 0, 1. This is lying on a circle, passing through these points. So that's why we are getting like this. So what is how to improve this? This is the thing. Actually, I just asked that what type of drawback you are seeing, what type of assumption is involved while driving this type of distance measure in mathematics. What type of assumption we just take? Assumption which we take while driving this type of distance measure is that all the components are equally important. All the components are equally important. We are just saying that that's why we are not putting any weight on that. So what is the suggestion? The people start putting weight so that just when they have put the weight, what happened? Just look. This equation has become in which form? A x square plus b y square plus c z square. A, b, c are what? The weights. So this is equal to something d square. So this is what? I have just intersected the plane with a conicoid. This is the equation of conicoid. Intersection of a conicoid. Conicoid is a conic section. If we just rotate it, the things which the surfaces which will appear. So if we are just think of the simplest case, ellipse. I rotate the ellipse. What it will become? Ellipsoid. It becomes ellipsoid. So how many now points are there which are equidistant? How many points are there which are equidistant? You just say from the center 4 points. A line like this and where it is intersected. So only at 4 points we are going to have our same type of results. But how much point we have just reduced? Considerable number of points. By putting the weights, appropriate weights, we have just reduced our mistake that we were committing. We are just saying all the points on the circle are same. Here now 4 points. Now we have to say that these 4 should also be different, because these 4 are also different. But this distance measure is not able to decide. So I suggest that one of the things is that with the help of hyperboloid, I was just thinking that if we just think of something like associating it like this, then there may be something we can think in a different direction.
Sir, like you asked a question, 2 points, in which condition we say 2 points are similar. So like in terms of distance, just try to remind like whenever say 2 triangles are similar,
Okay.
in terms of judgment, so in terms of congruence, so some properties are preserved. So
Yeah.
like if we find some homomorphism function,
Yes.
so maybe the distance function is a homomorphism.
Actually, in homomorphism, when you talk of a homomorphism, this concept comes in algebra. Okay. Once there is no distance measure is involved there. If you are just taking the things like, okay, I am just taking this type of distance analysis also here. So there is a term isometrically isomorphic. Isometrically isomorphic type of thing, or homomorphic isometrically.
I don't remember
Exactly what you are just asking. This is, I will suggest you that there is a book of which I just follow, Elements of Functional Analysis by Fleming. So this book I have just followed. So there is a term isometrically isomorphic or homomorphic, isomorphic and isometrically isomorphic. These terms are there, but here distance and isomorphism, these are 2 things which are, this is in the metric structure. Isometric comes in the metric structure. Homomorphic comes in the algebraic structure. With respect to some binary operation it comes. Okay. And this isometric type of term comes when there is a metric structure. Metric means distances structure is there. So when these 2 things together are coming, so there is a concept of linear metric. On the linear structure, we are trying to define the metric. So might be you might be asking for that particular part.
I'm saying if we consider, if we are able to show here, like instead of the distance, some homomorphic function exists, then we can define. I'm just thinking.
Maybe you just try. I have not tried that. Maybe it's a good thing you are thinking in this direction. I will not discourage, because many things are there which should be implemented, and we should just see that whether it is producing good results or not. So mathematically, what we are trying to do, we are just trying to implement that, okay, whether this thing could be implemented or not. So from this we have building material classification. Actually, हो गया है इसको. So this is comparison. Actually, what I am just trying to say that actually what the people have used, they find that since the distance metric are no longer valid for Intuitionistic persistence, so they have taken that we just want to conclude with 2 only. So in the Intuitionistic metric also, they just try to work out with two membership and non-membership. So what happened later on? Julia and Kripis again, in 2008 they have just shown that if you are just doing this, then the distances, what you will find that distances of this, if I just remove these 2 terms, then this will be the simple Euclidean distance. So they were just saying that you will be compromising with some information. So But in 2009, again one paper came in medical pattern recognition, and then they said that no, you cannot do this type of thing because we have practically implemented the things while we are detecting the bacteria classification, and we find that once removing the hesitancy part, the result is very poor. It's just only 85% of the detection. But in intuitionistic physics, that when we have taken the hesitancy also, the result was very good, so you should not remove it. Okay, so again the problem appeared, okay, we cannot remove it, the hesitancy with respect to it. So this is the thing which is continuity or continuity. This is actually, this requires more time, and these are the references, you can go through this, and
The explanation.
yeah.
What is about the triangular property?
Which triangle? Yeah.
The distance.
Distance. In the distance measure, the triangular property here we are not considering. Actually, we want to find the similarity. Only we are interested whether the two things are similar or dissimilar. So what is there, that we remove the triangular inequality, and we have taken in place of that triangular inequality A contained B contained C, so that we can compare whether these three sets, what is the relationship between distance and the containment. So that we can say that okay, these two opinions are different, or these two opinions are not different. Okay, so this sort of thing we have just removed from that. So that's why I want to discuss the intuitionistic, because this the second part which I was which was more mathematical, and I think this is the part which most of you are trying for that, because intuitionistic fuzzy metric space is that area where if you go through that metric spaces, there are a lot of distance structures are there. Okay, but people are unable to just implement on practical situation because of certain problems. So this is the where I have discussed to some of the computer science faculty, so I find that this is something interesting. So that paper is published in 2004 by J.H. Park. The reference is given if you go through that paper, and then from that, if you try to explore that, then it will be much better, because those structures are not very much used in classification problems.
Which is plausibility query. Evidence query, the partial evidence query, Shepherd query, which is very, very similar to intuitionistic set query. Like a degree, some ignorance will be there. Some of these they come to work. So, yeah.
Actually, there is a one very important set, neurosophic set. Okay. When I was just doing this problem, so what I find that actually, if you, what I have told you now, weight is a very, very important concept. Try to find out weight with different techniques. Okay, try to find out the weights with different available techniques. Okay, you will just find that the membership value will be reduced, non-membership value will be reduced, hesitancy will be reduced. There will be certain portion which will remain there. Okay, you have reduced. Now this is the membership value, this is the non-membership value, this is the true hesitancy. Now the fourth component will appear, and that component is the indeterminate. So this is actually intuitionistic fuzzy. You go through this set. The thing is that from this you can directly connect to the nucleosophic logic. Here only I was just searching the papers, so I find the philosophical discussions on that set. A lot of flaws. But if you go through like this type of things, then the thing is that there will be some mathematical connection. Explanation for the indeterminacy. Why the indeterminacy? Due to hesitancy, you have to say indeterminacy is up here. Due to hesitation, indeterminacy in computing the value of membership, non-membership will certainly be there. And that indeterminacy you have to take as a different component. But this thing you should do it by different taking weights. I have just submitted a paper. So this is the thing Yeah, just want to say.
Like big set, these are the terms like a common set.
Actually, the big set I have not gone through. So this is something where I have not expert. So I have just dealt little bit of fuzzy sets and the intuitionistic fuzzy sets, and then I'm just trying to go through neurosophic logic through this.
Any other question? If not, then you will have to speak up.